In this tutorial, we're going to look at what is called as named queries. Um, it's usually best practice to consolidate all the application queries in one particular place. And even if you're using a simple JDBC connection, it's actually a good idea to have one common place where all the queries that you use in the application are consolidated, because if you want to make any changes, you know where to go and make the change. If the queries are everywhere in the application, then it becomes very hard to maintain. Now, name queries is a way in which we can consolidate all the queries in a particular place, and it makes it easy to organize the queries, and it makes it easier to maintain as well. Then we'll have a look at what name queries are. Name queries allows you to write queries at the entity level. So say for example I have this user details class here. Now I can list out all the common queries that I would use for this user details entity, and I can refer these queries anywhere in the application. So that makes it a good way of consolidating all the user related queries in the user entity class itself. So the way I write name queries is by using the at named query. So this is the annotation that helps us to write name queries. I'm writing this below the entity annotation. Now I'll import this from Java x.persistence, and inside this I will write the name query. So this requires two parameters. One is the name of the query, and then the second parameter is the query itself. So I will give this name as you. Okay, I need to give the name here. Name equals, I'll give the name as user details dot by ID. The reason I'm giving this name is I want the query to be a query where I can supply an ID and get the user details object. So the query will be from user details where user ID equals question mark. Now again I'm having a parameter here. I don't want to hard code the parameter. Of course we know that this is a runtime thing. We might get a value in a variable and you want to substitute that here, but in essence this query gets me the user object where I'm supplying the user ID, and that's the reason why the name I'm giving is user details dot by ID. Again, it's a good practice to have the user details name here. So the entity name dot the query name is what I'm going to use, and it's a good practice to have the entity name in front of the named query so that it's easy to identify what we are trying to do. So say I'm having an address entity, it could be address dot by ID, so that way I can identify what the query actually does. So now that I have defined this named query here, let me save this. Now what I'll do is in my test class, I'm not going to do a session.createQuery, and I'm not going to have a string here. what I'll do instead is I will call another method of the session object. This is called session dot get named query. Now the session.get named query takes a string argument, and this is actually the name of the query itself. So it's going to be this one. Okay, so I have got the named query. I have to substitute the parameter because this named query has a placeholder parameter. Note that this can be both ways. It can be a positional parameter or a named parameter. Either can be used. So I will use query dot set integer 0. I'm just going to hardcode the value here just to test that it works fine, and pass the ID as 2. So it will have to return me user 1. I'm sorry, user 2. Okay, let's run this. Okay, user 2 is returned. Perfect. There is one more advantage of using a named query, which is that here I have actually written a HQL query. So this is actually a pure HQL query. Now what I can do is I can actually write plain SQL queries, native SQL queries, and that can still execute. So what I'm doing is I'm gonna write a select star from table name. I'm not going to use HQL. I'm not going to talk about classes and properties. I can use native SQL and I can write about table names and column names, and I can execute the query. In order to demonstrate just this, what I did was I have changed the table name here. It's user underscore details, and the class name is user details. So we'll see how it works when I'm querying the table directly. Now the way I specify a named native query is by using an annotation called at named native query. Now I'll have to import this from javax.persistence. Now again, this annotation takes the parameters name and query. So let me give the parameter user details dot, let me give a by name. I want to query by name this time. So I'll enter the query as, now this time it's a pure native SQL query. So I will not be referring object names. I will be referring the table name. I will not be referring field names. I'll be referring column names. And I will not start the query with a from. I will have to start with a select star from. So it's the entire SQL query. Select star from user underscore details, which is the table name. It's not user details, where username equals, just verify that that's the name of the column. Yeah, the name of the column is username. Okay, I'll again put a placeholder for this. It works similarly for a named native query as well. Okay, so I've defined the native query here. Now, one additional thing I can do here is specify the result class name. Now, why would I want to do that? If it is a named query, I'm talking in HQL language, and I know what is the class in which the list of results is going to be. I'm doing a select from user details. The class name is already available here. But when I'm writing a native SQL query, Hibernate will not know um, what object the results need to be in. So I can specify a class name here so that Hibernate knows what object to cast the result as. So what I'll do is I'll use this property result class equals. Now I'll give the class name, so which is user details. This should be the class name, not the string. Okay, so now we have defined this name native query. Let's save, and again we can use this native query in our session. So what I'll do is I'll use the same method, but instead of using this named query, I'm going to use this name native query. So just copy this name and paste it here. So the other change that I need to do is, since the parameter is a string in this case, so I will need to do a query.setString. I'll again hardcode a value here just to test. Save this. Okay, now let's run this and see what happens. There you go, user 10 has come up, but note that this time we have specified the whole SQL query ourselves. We do not rely on Hibernate to generate the query for us depending on the objects and the properties that we mentioned. We have directly entered the SQL query itself, and that's what runs. So the advantage here is that, say you have a stored procedure that you need to run, you can use this option and run the stored procedure. But still, it's always recommended to go for the HQL option, because the whole point of using Hibernate is to go away from SQL and querying and all that. HQL is a good alternative, and you would want to use name native query only when you do not have an option and you have to run queries directly. Result class is optional, but if you specify result class, the object that you're going to get is the object of the class that you've mentioned here. So that's why this works fine. I'm casting this as a list of user details, and this is a list of user details because I specified the result object to be of the user details type. So this is a look at name queries. In my next tutorial, we're going to look at another way to query objects in Hibernate, and that's by using the criteria API.